We're going to continue to learn how to factor, and today in 15.2, the I can statement is I can factor trinomials. So write the word trinomials. So factoring trinomials. Now hopefully you remember a trinomial is a polynomial that has three terms. That's why it's got the word tri in there. And we're going to start off in this warm-up by multiplying these binomials together. Now hopefully you've done this before recently. I know you did it last year, but we want to make sure that we can multiply these binomials. So here's what we do. We're going to take this x. Each term in this first one gets multiplied by each term in the second one. So the x is going to get multiplied with the x and with a negative 10. So we're going to do x times x, that's x squared. Then we're going to do x times negative 10, so that's going to be negative 10x. Then we're going to take the 3, this positive 3, and it gets multiplied with each one of those. Be careful that you drag that sign along with it. So it's a positive 3 times a positive x. That's going to be plus 3x. And then a positive 3 times a negative 10, that's going to be negative 30. Now, whenever you're multiplying binomials that are this similar, where they've just got an x here and then a number, an x here and a number, you're going to end up with two terms in the middle here that combine. So we have two terms here times two terms here. We've got four terms altogether, and these middle two, they're like terms. So we want to see if we can combine those. Now, I'm going to go ahead and write down the x squared first because that's the highest exponent. And then these two are like terms. We put those together. Negative 10x plus 3x, that's negative 7x. And then we've got this negative 30 for the constant sitting out on the end. So that right there is the answer then when we multiply these together. Now, the other part of this is solving these factoring riddles. Now, I'm hoping that you did 15.1.5. That was kind of optional, but it's a really good worksheet where we can go through and practice these. So this is a bit of a riddle here. It says find two numbers that multiply to be 20 and combine to be 9. Now, this might seem kind of silly, but I'm going to say it this way. I'm going to say find two numbers that multiply to be positive 20 and combine to be positive 9. Now, it's a little crazy on this one because if we don't say the sign, it's understood that they're positive. But if you get in this habit, it's going to help you in the long run. You'll see what I mean in a few minutes. So we need two numbers that multiply to be positive 20 that combine to be positive 9. Well, if they multiply to be a positive, they've both got to either be positive or they've both got to be negative. And if they combine to be a positive, they've both got to be positive. So I need two numbers that multiply to be 20 that combine to be 9. So I'm going to say this. The two numbers that would multiply to be 20 would be 1 and 20, but you can't combine those in any form to make a 9. We could do 2 and 10, but those multiply to be 20, but you can't combine those to be a 9. The best we could do is maybe 12, or if we put them together by subtraction, we'd get an 8. And then we've got, let's see, 2 goes in there, 4 goes in there 5 times. Let's see, those multiply to be 20. And hey, 4 and 5, you could make a 9 out of those. So that would be 4 and 5, and they both have to be positive, okay? So I'm going to go ahead and circle that. That's the answer to that riddle right there. Now we want to find two numbers that multiply to be negative 12 that combine to be negative 1. And again, notice how I'm saying the sign in front there. It's just a very good habit to be in, regardless of whether you have to say the sign, like when it's positive, but just get in the habit of doing that. So we need numbers that multiply to be negative 12 that combine to be negative 1. Well, the way they're going to multiply to be a negative is one would have to be negative and one would have to be a positive. So let's try it this way. 1 goes into 12 12 times, but you can't make a 1 out of those. 2 goes in there 6 times, but you can't make a 1 out of a 2 and a 6. 3 goes in there 4 times. Well, hey, wait just a second. If you use a 3 and a 4, you could make a 12 out of those somehow, so we could multiply them. But here's the question. One of them has to be negative. So would it be a negative 3 and a positive 4, or a positive 3 and a negative, positive 3 and a negative 4? Well, think about this. We're going to multiply them together, and we're going to get a negative. So again, one of them's got to be negative. But when we combine them, in other words, when we add them together, the answer has to be negative. So when we combine them, the bigger one's got to be negative, so that means it's going to be a negative 4. So double check me here. Positive 3 times negative 4, that would be negative 12. And 3 minus 4, that would be negative 1. So those are the two answers right there. That's the answer to that riddle. It only has one answer. We're going to go with that one. So it says polynomials that have three terms are called trinomials. Again, just kind of reiterate the point right there. Now, terms are separated by plus and minus signs. Now, it's useful to write polynomials as multiplication problems. So what we do is we factor them. Remember, if somebody says factor this, they mean write it as a multiplication problem. Now, the trinomials that we're going to learn, for the most part, they're going to be quadratics. Quadratic means square, so that means the highest exponent is going to be 2, and that's why we say like x squared or y squared or, yard squared, whatever it happens to be. Now, there are two categories that we're going to learn. There's an easy type of trinomial and there's a hard type of trinomial. The easy type of trinomial has a leading coefficient of 1. So notice there's a 1 missing right here. If there's no number in front, then it would be a positive 1. If there's something other than 1, we're going to call that a hard trinomial. Now, we're going to learn the easy ones today, and we're going to utilize some of the stuff that we did in the warm-up, and then we'll learn how to do the hard ones in the next section. And we're going to call this the guess and check riddle method. So the guess and check riddle method. So we're going to use what we talked about up above. So let me slide down here so we can still see that. There we go. So here's the deal. We do this every single time. So notice this is an easy trinomial because there's a 1 right here. And this is how cool this is. We're always going to break this up into 2 different binomials. Okay. So we're going to have 2 terms here and we're going to have 2 terms here. These first 2 are always going to multiply together to be that x squared right there. So the way we're going to do that is we're going to have an x here and we're going to have an x there. A lot like the warm-up problem that we had here. So remember we had an x plus 3 times an x minus 10. These 2 multiplied together to be that leading x squared right there. So it's always going to go like this. We're going to have an x here and we're going to have an x here. And then we ask ourselves a question. We ask ourselves, what 2 numbers, so we've got to have a number right here and a number right here, what 2 numbers would multiply to be this number and combine to be the middle coefficient? Don't worry about the variable. That's going to work out on its own. So we're looking at these 2 numbers. What numbers multiply to be a 20, positive 20, and combine to be a positive 9? So multiply to be this number, combine to be this number right here. So what 2 numbers multiply to be a positive 20, combine to be a positive 9? Well, that's our 2 numbers right here. So I'm going to write down a positive 4 right here and a positive 5 right here. And believe it or not, we're done. That's it. That's as hard as it is. Okay, when we're doing easy trinomials, it works out just like this. So we just ask ourselves this riddle question. What 2 numbers multiply to be this one, combine to be that one? We write those 2 numbers down right here, and we're all set to go. Of course, we've set up the parentheses, and we've got that x starting off there. Now, how do we know that this is the right answer? Well, watch what happens if we distribute. So x times x, that's x squared. X times 5, that's positive 5x. 4 times x, that's plus 4x. And 4 times 5, that's positive 20. These 2 put together, we get x squared plus 9x with those 2, and then plus 20. We get this original thing right here. Now, I've written this in a different color because you can always factor or always check to make sure that you got the right answer by multiplying them together in the end. If you get the same thing that you started with, you know you got the answer right. Now, one typical question is, can I write these in the opposite order? Like, what if I did this and I said 5 and 4 rather than 4 and 5? Well, if you think about it, because multiplication is commutative, as long as I'm dragging the right sign with it, this is a positive 4, I could have put a positive 4 here, and I could have put a positive 5 right here. It would have worked out the same way. This just would have been a 4x right here and a 5x right here. We still would have gotten the 9x right there. Okay, so let's take a look at the next one. On this one, again, we start off like this. Whoops, let me change colors again. We want a set of parentheses. And again, this is what makes these easy. If this is an x squared, the only way to make that would be to have an x and an x. And then we ask ourselves, what multiplies to be this number right here, the negative 12, and combines to be that number right there? I'm going to put that coefficient right there. It's a negative 1. So we need 2 numbers that multiply to be negative 12 that combine to be negative 1. Well, we asked and answered that question up here, so I'm going to put down a positive 3 and a negative 4, and I'm going to circle that. Literally, we're done. Okay, that's it. Now, if you want to go through and double check, and I'll do this one more time, I'm not going to do this all the time. I'm going to do x times x, that's x squared. X times negative 4, that's negative 4x. 3 times x, that's 3x. And 3 times negative 4, that's negative 12. So when we combine the 2 numbers together right here, we've got a negative 4x and a plus 3x. So we've got our x squared leading off right there, and then we've got a negative x, because when we put them together, you get a negative 1x, and then minus 12. This right here is the original problem, so we know we factored that the right way. Now, there is a way that you can get around guessing and checking. Sometimes that's a bit of a hassle, but it involves taking square roots, and that really shouldn't be a surprise because we've got squares here. Shouldn't be surprised that going the other way we've got square roots involved. But it doesn't give us a mental workout, and it doesn't help us use our recall as much. And honestly, it's a little bit, in my opinion, a little bit longer, and it's not nearly as much fun, if you can call this fun. So we're going to come down here, and I'm going to show you what our factoring list looks like so far. So again, and I noted this before, we can always double check and make sure we got the answer right by multiplying them together and then simplifying. If you get that original polynomial, then you know that you've got it right. So here's what they look like now. We've talked about rule number 1. It's always take out the GCF. So if there's a greatest common factor that you can take it out because it's always going to make your life a little bit easier. Then, if there are three terms, I told you this was to be determined. If it's the easy type, we use the guess and check riddle method. And if it's the hard type, that's going to be determined. We're going to leave that for tomorrow. If there's more than three terms, then we do that grouping method. We group the first couple together and the last couple together. And then we always want to factor completely, and don't forget to include all the factors in the final answer. And then we want to make sure that we circle this. So I'm going to slide down here. We're going to take a look at these four problems. I've got an asterisk by this one for a couple of reasons, so we'll take a look here. So you'll notice that we start off with a t squared. So this is an easy type of trinomial. So I'm going to put a set of parentheses here. So I'm going to put a t right here and a t right here. I'm looking for two numbers that multiply to be 15 that combine to be -8. Now, I need to say this the right way. They need to multiply to be positive 15 and combine to be -8. Multiply to be positive 15. Well, if they're going to multiply to be a positive and combine to be a negative, they better both be negative, okay? And they've got to multiply to be 15. So I'm just going to make a list here. 1 and 15 would multiply to be 15, but you can't make an 8 out of those. 3 and 5. Well, those would multiply to be 15, but how do we get them to combine to be -8? They'd have to both be negative. So we're going to have a -3 and a -5. Do these multiply to be positive 15? Yes, they do. Do they combine to be -8? Yes, they do. So we circle that, and that's our answer. Again, if you wanted to double check, you could multiply these together like we did up above. We're not going to take the time to do that here. So another easy trinomial on this one. So I'm going to start a set of parentheses with an x, another set of parentheses with an x, and then we need numbers that multiply to be -13 that combine to be positive 12. So let's stop and think about that. What multiplies to be 13? Well, that would just be 1 and 13. It's a prime number. There's nothing else that would work here. So these are our only two possibilities. So how are we going to get this to multiply to be a negative but combine to be a positive? Well, in order to multiply to be a negative, one of these has to be a negative. So it's either a -1 or a -13. They can't both be negative because otherwise that would multiply to be a positive. But if they're going to combine to be a positive, that means the biggest one's got to be a positive. So this one's going to be a positive, that one's going to be negative. So I've got -1 here, I've got positive 13 right here, and that is the answer. Now I'm going to go ahead and erase this work right here and just remind you, if you wanted to multiply through, you certainly could. And also, if somebody wrote positive 13 on this one and then a -1 on this one, that's totally okay. You can switch up the order that the factors are in as long as you drag the sign in with it. So if you put a plus 13 right here and you put a -1 right there, then that would be okay. Now I am going to show you that if you were to do this the wrong way, so let's say we said -13 and then we said +1. I want to show you what happens there. Well, when we multiply here, we get x squared. When we multiply here, we get positive 1x. When we multiply here, we get -13x. And when we multiply here, we get -13. So this part and this part, those are totally okay. We've got an x squared and we've got a -13. But watch what happens when we combine these together. We get 1 minus 13, so that would be -12x. Notice that it doesn't match up right, so this would not work. You can always multiply together and double check and see if you got it right. Now, the last couple are kind of interesting. Notice that this is an easy one, so we're going to start off with an x in a set of parentheses and an x in a set of parentheses. We're leaving room for those constants to finish off each one of those binomials. And then we need some numbers that multiply to be positive 36 and combine to be -12. Now, please get in that habit. Say the sign of the number as you go through. So we need some numbers that multiply to be positive 36 that combine to be -12. So I'm going to start off with 1 and 36. Now, 36 is kind of a hassle because there are so many different factors. So 1 and 36, there's no way we can make a 12. 2 goes in there 18 times. You can't make a 12 out of a 2 and an 18. 3 goes in there 12 times. You can't make a 12 out of a 3 and 12. Next one would be, let's see, we'd have 4 and 9. Okay, you can't make a 12 out of a 4 and a 9. 4 and 9 make 13, so we're pretty close. So the last factor is 6. 6 goes into 6 goes into 36 6 times. So what if we did this? What if we did a 6 here and a 6 here? 6 times 6 is 36, so we've got some numbers that work out that way. And can you make a -12 out of a 6 and a 6? Well, you can make a 12 out of a 6 and a 6, but what if we made them both negative? Let's see if that would work. -6 times -6 would be positive 36. So remember, we needed some numbers that multiplied to be positive 36 that combined to be -12. -6 and 6 would work because they multiply to be a positive 36 and they combine to be a -12. So that is your answer right there. A little bit unique that it's the same number. Now, if you take a look at D, you'll notice that there's something weird about this. So this one starts off with an x cubed. Remember I said this was going to be easy trinomials? They've got to start off with an x squared. Well, notice that we've got x cubed, x squared, and then an x. So I'm going to zoom in on this one just a little bit, and we'll take a look at that. So remember the first rule in factoring. It's always take out the GCF. So we're going to take out an x. So if I take out an x, here's what I'm left with. I'm left with an x squared. I'm left with a negative 7x, and then I'm left with a negative 30. Okay? Now this is a trinomial, so let's ignore this for the time being, and it's an easy trinomial, so let's write down this stuff. So I've got an x here and an x here, and I need two numbers that multiply to be negative 30 that combine to be negative 7. Well, if you remember, look up at the top of your sheet, we did this one in the warm-up. So we actually did the original problem in the warm-up. So two numbers that multiply to be negative 30 that combine to be negative 7 would be, let's put a positive 3 here and let's put a negative 10 right there. Okay, now again, if you wanted to put the negative 10 right here and the 3 right there, that would be totally okay. So they multiply to be negative 30, and if you do a 3 minus a 10, you get negative 7. Now, if you just circle this right here, that is not the entire answer, because remember, the last rule is always make sure you include all the factors. The last factor was this one right here. It's the one we took out originally. Okay, so I'm going to snap back to full size here. So we took out the GCF. What was left was a trinomial. It was an easy trinomial, so we did an x here and an x here in a set of parentheses. And then we were looking for two numbers that multiplied to be negative 30 that combined to be negative 7. Negative 10 and positive 3 would fit the bill. And again, if we go back up to this original one right here, let's see, if you have x squared minus 7x minus 30, the original factors were x plus 3 times x minus 10. The only difference on this one is we had that x sitting out in front. Okay, so go ahead and fill out the the self-assessment on how well you feel you can factor those easy trinomials using this guess and check riddle method, we'll call it. And then good luck on the assignment.